Hello, good afternoon, testing. Can you hear my voice?
Yes, yes, I can
Clear.
hear.
Okay. Okay. We have another 2 minutes before 2. We wait until our participant join our webinar today. Okay. All right. Let's begin. Hi, everyone. Good afternoon. For those who just joined us, welcome. Welcome, everyone. I'm Marianne from Utah. I'm also the Kuala Lumpur Engineering Science Fair Secretariat. So we would like to welcome you to today's webinar entitled, Where is Our Future Habitat? Thank you for taking your time out and being here today with us. Okay, I would like to remind you, if you get disconnected, just please join back using the link given earlier. All right. The objective of this webinar are to create awareness on the pollutions that causes the climate changes and natural disaster. And it's also to discuss the challenges of habitat that mankind will face in the near future, to inspire the youngsters to think of solutions to solve the problem of tomorrow. So today we will be looking at the following topics that you may wonder: the pollution, the global warming, sea level rising, climate change, natural disaster, and food crisis are making the earth less and less habitable. Instead of looking of habitable exoplanet, another feasible option could be underwater city. Benefits of underwater cities will be elaborated. The challenges of building underwater city will also be discussed, and the respective future skills, technology, and solution that need to overcome those challenges will be discussed also. So there will be a Q&A session at the end of the webinar. If you have any question, please type them into the Q&A box. So I would like to introduce you to today's our speaker. It's Mr. Chee Heong. He received his Bachelor of Science in Applied Physics from University Kebangsaan Malaysia, UKM in 2000. He is currently an assistant lecturer at Center for Foundation Studies, Kampa Campus, University Tengku Abdul Rahman, Utah. And he's currently teaching foundation physics courses for more than 14 years. His interests are in physics education and e-learning. So without further ado, we would like to turn over the time to Mr. Lee.
Thank you, Paul Maria. Good afternoon to all. Can y'all hear me? Can y'all hear me? Okay, thanks. Okay, welcome to the talk. Okay, the title will be Where is Our Future Habitat? Okay, why I actually have this idea on this talk is actually because of the recent so-called years of problems that we face, including global warming, the climate change, and so on. Okay, so we should actually seriously look into our possible future habitat. Okay. Okay, so my first question is Earth still habitable beyond 50 years from now? Right, 50 years, if we actually look at it, it seems like very long. okay, but it's actually very fast that human will going to face it, okay, in 50 years time. So is Earth still habitable beyond 50 years, judging from the current situation? Okay, that's a question that we should actually look into. Okay, I'm not really sure, but I think it will be very challenging. Okay, so do you think that the question is unfounded? Okay, it is over so-called pessimistic on the situation, the current situation. Let's look at some of the facts. Okay, wait, the number of disasters that we have, wait, over the past decade, right, from 1900 years until 2010. Okay, this is the statistic that we have collected. Okay, so you can see the number of disasters actually increasing. Okay, the graph on the left is actually all disasters, which include the drought, the earthquake, extreme temperatures, famine, flood, insect infestation, volcanic eruption, and so on. Okay, so if you only look at the earthquakes, flood, and also the cyclones, okay, of the graph on the left, then you can see floods is actually a major problem to us, okay, over the years. So if we were to actually look at the statistic for the past 10 years, okay, from 1998 until 2017, okay, the statistics that we have collected, 43% the disaster that we face is actually flood, right, followed by storm and so on. So these are the top 10 countries in terms of the number of so-called, okay, the number of disaster and their losses, okay, for the 10 years. Okay, so you can see in USA, they're actually amounting to $944.8 billion. Okay, so natural disaster with most economic damage worldwide in 2019, last year alone. Okay, so tropical cyclone Hagibis in Japan, $17 billion. Tropical cyclone Lakima in China, $10 billion, and so on. So these are the top 5 only. Okay, so with that, it's already amounting to like 50 plus million dollars. And the number of victims affected in terms of millions. Okay, so in India, 20 millions due to the cyclone. A drought in North Korea, 10 millions, and so on. So you can see actually quite a number of victims affected by the natural disaster worldwide in last year. So, and we look at the recent COVID-19 pandemic. We look at the statistics, how many involved and the deaths. Okay, this is not just COVID-19 only, it's actually from the past pandemic, the largest from Black Death in 1347, which actually amounting to roughly 75 million people. Okay, and COVID-19, up of today is almost 1 million already. This was actually a statistic in May. Okay, so you see a lot of life lost. And up of yesterday, in Malaysia, already 10,000, 10,500, and that's 133. So global cases is 980,000 cases. That's actually death, I'm referring to that. Right? And that's not all. The challenges that we are facing, pollution, degradation of water quality, poorer air quality, climate change, which include global warming, rising seawater level, heat waves, effects on ecosystems, food security or crises, social and security problems, diseases and health issues, higher cost of living. Okay, and if you can imagine, if the natural disaster continue to occur and increase, the problems that you are going to face in the next year is going to be more severe. So let's look at the recent incidents around the world. Okay, we have the wildfires in Oregon, US, which causing the San Francisco sky to be orange at noon. If you look at the picture, it's not actually in the evening, it's not at the night. It's actually during the noon time where the whole sky turned into orange. So you can imagine how poor the air quality will be. Okay, for those actually staying nearby in San Francisco or Oregon. And if you look at the pictures at the bottom, okay, it's actually cases happen in more on the central and northern China, southern China actually, sorry, it should be southern China of the, southern part of the China, not northern. Right, it's actually caused by the Three Gorges Dam, okay, releasing flood waters, which they cannot hold any further. Right, it's over their limit already, so they have to release. And this release and plus the heavy rain, okay, for the past few months, it caused a lot of places to be underwater or flooded. Right? As you can see, it's actually quite serious. The whole area at the center of the pictures here, okay, is actually being flooded as high as 1 story or even 2 stories. And for the picture on the right, okay, the flood water actually from higher place actually fall down just like waterfall. And the recent flood in Kuala Lumpur, the whole Masjid Jami become an island. Okay, so you can see that if you look into the past cases, okay, the natural disaster is getting more and more serious. So back to the question, will the Earth be still habitable? And the other case will be actually the Australian fires. If you still remember, starting from end of last year until like the March or April this year, how many animals being killed? More than 1 billion animals being killed. Okay, so we have to ask ourselves, and pollution. Just now was actually natural disaster. Then look at the pollution. The land pollution, the ocean pollution, the air pollution, and the oil spill on the sea. Okay, these are some major pollutions that we see day to day, and there are other pollutions also. Let's look at one of the source of pollution, right? The plastic pollution.
Mr. Lee?
Yeah.
Sorry, Marian here. Mr. Lee, there is some noises, like static noise from the audio, Mr. Lee.
Is it?
Yes,
Sorry.
yes.
I try to, let me see, maybe I lower the volume.
Okay.
Is it better now? Is it better?
Yes. Okay, at my side.
Okay, this is actually based on this year. So Coca-Cola producing, 2.9 million tons of plastic packaging, okay, and followed by PepsiCo and so on. These are the label of the countries involved. So we are still actually buying all these products with producing all this rubbish plastic pollution that will pollute our earth. Okay, and let's look at the so-called temperature anomalies, or the increase of Earth global surface temperature over the 60 years here, okay, from 1880 year until 2020. The temperatures keep on actually increasing and getting faster and faster, the increase in temperature. And if you actually look into study, if the temperature is above 1.5 degrees, then it's going to cause greater disaster to the Earth. Okay, so now they are actually having some efforts to try to control the increase of temperature less than 1.5 degrees Celsius. So the increase of global temperature or global warming, okay, causing the sea level to increase. Okay, although the increase is small, if you actually look at the numbers, it's actually like less than 1 mm per year. But if you look at the projection, it's going to increase sharply after this. So are we actually prepared for all this? Bear in mind that most of the major mega cities, they are actually close to the sea. If you look at the map where major cities are located, or the Tokyo, the Shanghai, the Shenzhen, Hong Kong, or those in Asia, and those like California, and so on. Those actually close to the sea. Okay, major cities are actually close to the sea. So if sea level is going to rise, just like Singapore, okay, in the old days we never heard that Singapore will have flood, but in recent decades we start to hear there are a serious flood in Singapore Island. Then we look at the countries that facing the most ecological threats in 2020 only. Or this is actually based on 2020, this year only. So how many countries have zero threat? Okay, only this limited area. Okay, those serious one will be here, right, with dark brown or red color. So Malaysia is actually having one or two, okay, around here. So what are the ecological threats that include in this graph? The population, water stress, okay, the food insecurity, droughts, floods, cyclones, and rising temperature and sea levels. How about the next 10 years? Okay, so the next 10 years, if you look at the left end of the graph, the top 5 is actually related to environmental. Okay, extreme weather, climate action failure, natural disaster, biodiversity loss. Actually, the list is very long. 5 are all related to environment. For the next 10 years, it's predicted. Okay, it's actually based on the survey done, okay, which will include businessmen, government, civil society, and thought leaders from World Economic Forum. So back to the question: is Earth still a suitable habitat for humans beyond next 50 years? Do we have other options? The options that human is exploring: migrating to habitable exoplanets. Bear in mind that the nearest is actually 4 light years, which will be Proxima Centauri. So how far is 4 light years? Anyone have any idea? Is it too soft? Okay, I'll speak louder. Anyone have any idea how far is it for 4 light years? Let's look at this calculation. From Earth to Moon, it's about 384,000 kilometers. So if we take the fastest rocket, which is traveling at speed of 16.26 kilometers per second, this is per second, you will take roughly 8.6 hours to reach the moon from Earth. To reach the sun, which is 150 million kilometers, you'll require almost 5 months. And for 4.24 light years away, you require 67.4 million years. So do you think that it is possible for us to migrate to this exoplanet? Bear in mind, we haven't actually even reached the Proxima Centauri and actually take a look at the actual situation. So-called the possible habitable exoplanets are actually based on so-called the studies of the spectrum that we receive from this planet. Whether it has water, what are the gases that it has in its atmosphere, and so on. So we haven't reached there to actually take a look yet. We haven't done the field survey yet. We don't know how the planet will actually be. So thinking of migrating to exoplanets basically is impossible. Okay, so human will not migrate to other planets, said by Nobel winner. Okay, so we have to be realistic. I don't think that we can actually migrate to the moon overnight and so on. Actually, there are a lot of issues that we have to overcome. First, of course, is the air, the water, the source of our food, and also the gravity. We live on Earth, our body is adjusted to the Earth gravity, which is 9.8 meters per second square. If you go to the moon, it's only 1.67. So our blood flow will be affected. Okay, blood will not actually flow easily, okay, to our brain or actually leg and so on, right? Because the gravity is very light and so on. So there are a lot of challenges. Even if you were to build a house there, how are you going to transport those concrete materials and so on? And you can't really like apply forces on the moon surface also. Okay, we have never done that, and we don't know what will be the effect. Unlike Earth, which is much larger than the moon. Okay, so where could be our future habitat? Any idea? Actually, based on the climate change. Okay, later I'll actually I have it in the list also. Okay, humans actually start exploring on the floating cities, but I don't think that is the final solution to the challenges, the threats, or the climate change, the pollutions that we are actually facing now on Earth. Okay, so one of the possible solution will be actually underwater world, right? Could be our future habitat. Right? Why? Right? Because firstly, seawater covers 71% of Earth's surface. Okay, imagine the Earth that human has already covered. Okay, and the mass population or congested population that we face, right, with less than 10% on the Earth's surface that is suitable for human to live, and seawater actually covers 71% of the Earth's surface. So we have larger area to spread out the population, and also quick and easy and cheaper access as compared to exoplanet. Right, to fly to the nearest, it requires 67.4 million years. But to actually access to sea, right, to our ocean, it's actually much faster. And of course, definitely will be cheaper. Right? And many studies have been done on ocean and marine, right? Compared to exoplanet, which we have never reached there. Right? And very limited studies on that also. But ocean, we have a lot of study research done on the ocean. And less natural disaster compared to the land. Okay, no flood in the ocean. We are actually in the water. No storms. Storms is actually on surface. Right? Of course, there are underwater cyclone and so on, but not much. Okay. Extreme temperature, because we can avoid extreme temperature because the temperature of water is rather stable, and many more. And there are existing structures, there are under construction structures and planned underwater structures for research, exploration, recreation, and tourism currently around the sea, okay, in on Earth. Okay, so there are already structures there, and there are some under construction and some planned structures to be built. So we already have so-called some background on that, okay, to prepare us for the underwater city. So let's look at some of the photos of existing underwater structures. Right? First is actually the Ita Undersea Restaurant. Right? Of course, it's a restaurant. It doesn't actually expect you to stay very long there. It's actually for so-called enjoyment. Maldives in Maldives. And Jules Undersea Lodge is actually previously a research unit, right, somewhere in Florida. Great Sea Star in Gilead, Israel, and also Aquarius Reef Base. Okay, this is actually a lab research in Florida. Okay, and the latest one, okay, which just actually finished built by this year, is actually the Hurawa Key Undersea Restaurant. It's actually the largest undersea restaurant built on Earth. Okay, and this is actually a photo from its website. So you can see the book now button here. You can actually book, okay, to actually have your meal, okay, in this restaurant. So there are already so-called certain level of technology that enable us to build structures under the water. That's why underwater city is one of the possible solutions. Let's look at the under construction underwater structures. This is actually a hotel, or it's called Planet Ocean Underwater Hotel. The purpose of building this hotel is actually for those actually to enjoy the undersea world. The cost over one night is, I think, roughly a few thousand USD, and the money will be used to fund the coral research, living room, dining room, and so on. Okay, and it's estimated to cost 10 million. So if you are rich, you want to have one, or you can actually ask the company to build for you. It costs 10 million USD, around that. So this is actually considered a big apartment. Right, this is another water discussed hotel. Okay, at first it was actually planned to construct. Okay, there's a plan to construct, but due to some financing problem and the recent withdrawal of one investor, so the project is basically stopped. Okay, so it's actually a hotel, a water discussed hotel, somewhere supposed to be in Dubai. Okay, so it will cost 45 million for this project. So another planned project, this is actually planned project, Ocean Spiral, which costs about $25 million. Right? It's actually designed by a company in Japan. Right? This one whole structure is supposed to host about 5,000 people. So it is actually self-sustained. Okay, and you can see in the picture, okay, on the left, right. Okay, so at the background there are a few more units. So this one actually, if I remember correctly, is about 10 kilometers for the whole height. Alright, the energy will actually from the base, generated from the base and so on. Okay, so they are already actually idea of building underwater city, although it's actually not so popular among normal laymen. Right? To us, it's like we never think of that because we are actually comfortably live on land. Right? We do our we conduct our normal activities on land. So we never actually thought of the need to actually to have all this. And to us, it might actually limited to those elite which are rich and so on. Okay, but if we actually judging from all the challenges that we have seen just now, the natural disaster, the climate change, and so on, or the challenges that we are going to face. Okay, and there's no way for us, right, to grow. Right, we are actually so-called locked on Earth. Then we have to think of where we can actually live. Okay, so one of the possibility will be underwater, but we are still actually so-called have limited study on this. Right? We have some study about the ocean, the condition in ocean, and so on, but we do not have major studies on living under the sea for long term. Okay, how are we going to actually get the power supply and so on? So another larger scale, or just now about the spiral city, Ocean Spiral, designed by the Japanese company, it's actually to host about 5,000, 3,000 to 5,000 per unit. This sub-biosphere is designed for self-sustainable underwater world. This is partially submerged. It is supposed to be fully submerged, because this is a design only. But there's idea to construct this. The only problem is where to construct and the funding. Okay, they need to look for the funding because due to this COVID-19 pandemic, also all the governments are actually have limited money, and to them it's not so urgent to consider. But to be realistic, we have to start to actually study how to build a self-sustainable underwater world, underwater city. Okay, so this is actually a biosphere which actually has its own forest-like, factory and so on. So everything will be self-sustained inside. So power generation inside and so on. Okay. So this actually plant, right, is going to build succeed. Okay, looking for the funding. So let's look at the criteria for livable underwater habitat. What are the criteria that we have to actually fulfill in order for mankind to live in water? First is uninterrupted fresh air, fresh water, and food supply. This is the basic thing that we need: air, water, and food. So if we are going to actually have a city underwater, how are we going to get fresh air? Are we going to filter oxygen from water? Okay, to raise the oxygen with the aquatic lives? Okay, no. We are supposed to actually try to produce oxygen by ourselves instead of actually like getting oxygen from seawater. So where are we going to get the fresh air? And if we have large population underwater city, okay, then we need to have sufficient air, fresh water, and food supply. So that's the first challenge. Power supply, secondly, power supply or energy supply. Okay, because we can't live in the dark, and we have a lot of electrical appliances, gadgets, and so on. We need energy, and we need to have this power to produce heat for us, because our body temperature is around 36, 37 degrees Celsius, and underwater it is actually much lower. So we were actually getting cold, stay long time under the water. So our structure must able to produce heat. So we need power supply and energy supply. Then as a human, we can't live in a very confined spaces. Like those actually stay in Hong Kong where their units are very small. You actually have will cause problem in our mental health. So we must have sufficient physical space. That means we must have so-called space for us to move around, to have social activities, to live. Okay, so it cannot be very small unit, or it's not healthy for us. Then logistic, to travel from one underwater city to another underwater city and so on. So we must have the logistic ready. And sustainable ecosystem. This include inside the underwater city as well as with the ocean, the underwater world itself. So we will actually look at the challenges, then you understand more about this ecosystem challenge. And we need the law and order. This is very interesting. Okay. Because the underwater city, okay, the unit is supposed to be modular, like Lego. You can actually plug and unplug. Okay, so there's this theory whereby if there will be actually so-called many underwater cities. So each of them from one region to another region, they might have different laws, and you might actually like move around because you can detach your own unit and actually bring it to another city and attach to that city. If you actually dislike the law in your region and you want to actually go to another region and stay there. So there are laws and orders that the people for this underwater city that they have to actually adhere to, they have to follow. Okay, so these are some of the criteria that to make the underwater habitat to be livable. So you can imagine, are we actually really prepared for this? Currently, do we have the solution for all this? We have yet to have. So the possible environmental impacts, this will be actually the ecosystem that I mentioned just now. Right? As we move to underwater, right, to create our city, we are going to cause pollution again. The water pollution from our wastewater. We are going to produce waste. So if we do not handle properly, it's going to pollute the water. Okay? And we are going to cause light pollution also. Okay? Light pollution, why? Okay, definitely our unit will not be fully concrete. There will be glasses and so on. And we are going to have light inside the unit. So light will be emitted out to the ocean. So we are going to actually pollute the the sea world with light. And if the city is large, basically the whole area will be lighted. And that's going to actually affect the whole ecosystem and sound. Although we can actually build some soundproof, so-called soundproof structures, but definitely there will be still sound emitted to the ocean, which will disrupt the life under the water. And EM radiation, right? Apart from light, which is electromagnetic radiation, there are other electromagnetic radiation. Okay, for instance, we are going to use handphone wireless units, right, whereby there will be EM radiation. Okay, as we are using handphone nowadays. So when we move to undersea world, definitely we're still actually using handphone. Okay, so there will be EM wave radiation, and we have very limited study on this, how the EM radiation is going to affect the aquatic life in large scale. Imagine not one, if there are 5,000 people staying underwater city and they're using handphone, the amount of radiations that will be radiated into the sea and the effects, the impact, okay, is not well studied yet. And then because we are living inside the underwater, the sea, okay, so we are going to cause the change in the temperature of the seawater. We are going to make the seawater warmer. So as the life, the aquatic life, even the corals are sensitive to temperature. So we are going to cause some impact on the aquatic life and also those plants or underwater plants. And also the change in the pH, the acidity of the seawater, definitely that's going to cause the change in the pH of the seawater. Okay, if the seawater become more acidic, then it's not suitable for coral and so on. So without coral, then the aquatic ecology will be actually affected and so on. So there are a lot of so-called possible environmental impacts, negative impacts that we are going to introduce for the underwater, okay, world. So before we can actually so-called build the underwater city, we have to consider all this, okay, the criteria that we need to live underwater, and also how not to actually cause the negative impact on the environmental impacts for the underwater ecosystem. So since we might actually start to migrate, okay, into this underwater world, okay, in the next 50 or 100 years. So there must be a start in the study and research, okay, to build up all these criteria and also to overcome all these negative impacts. Right? So it's important for us to start to prepare for all this. So to overcome all this, so there are a few technological challenges of underwater habitat. Okay, so as mentioned, the source of energy to power the whole habitat. Okay, so one of the possible current technology that we can actually apply is actually the solar energy, where we actually build the solar panel on top of the water surface. Then the energy collected from solar panel will be channeled. Okay. Secondly, will be actually the geothermal energy from the seabed. So we can actually so-called drill in, okay, to certain spots where we can actually collect the heat from underground. So there are some existing technology that we can actually make use of, but we still have to consider other better solution. Okay, other than this source of energy or to power the whole underworld habitat, other technologies that we actually should look into is how to generate O2 and capture CO2, okay, or the exchange of air. So we need to think of how we can actually generate O2. Okay, one of the studies that being done is actually to have, of course, it's limited to one person. Or he actually have this so-called algae or bioreactor algae, the koi, whereby the algae will actually absorb the CO2, carbon dioxide, and release oxygen. Okay, so he actually rely on that, right, to sustain himself for a few days. So there is a possibility that we can actually so-called make the scale larger. So other than that, okay, we need to control and maintain the pressure as mentioned, as asked by one participant just now. Okay, as we go lower under the sea, the pressure will increase. How can we actually control and maintain the pressure inside the structure itself, throughout the different heights, and also the humidity within the habitat itself, because it's underwater world, so it's going to be humid, and humidity will actually link to certain diseases, which is not suitable for those asthma people, patients, and so on. Okay. Next will be how to produce sufficient food and fresh water within the sustainable habitat. Right? We actually looking at self-sustainable habitat itself, and also the transportation and communication mode. Right? How to actually move around and how to communicate. Right? Which hopefully can minimize the disruption of the ecology for the underwater world. Right? And how to process the waste produced. Right? As you know, we humans are actually not good at actually reducing waste. Look at the number of food waste, okay, around the world. Right? We actually waste more than tons of food every day on daily basis. Okay, so that's only the food wasted. Right? How about other waste that we actually produce? Wastewater, right? The sewage, okay, the rubbish, and so on. So how are we going to process, right, for this underwater habitat? Then how can we actually control, okay, have the technology to control the emission of heat, light, sound, and EM radiation from emitted into ocean? Right? Let me look at a few questions being asked. Okay. Speaker sound is too soft. I hope it's actually overcome already. Like how far down the sea is safe for underwater habitat? So I have answered that. Okay, so far okay. So you can see the challenges that we are facing on land now. Right, all the pollutions, the climate change, the rise of the seawater level, the spike of the temperature itself, and so on. As the temperature actually increases, the sea level increases. When the sea level increases, the flood is going to be, and the flood, the natural disasters is getting more and more serious. Then we have more lost life, the money loss, and so on. And it affects our human life. Okay, so affect the economy of the world and so on. So rather than actually wasting time on how to prevent the sea from doing damage to our society, our city, and so on, why not actually start to look into underwater habitat? Right? As you can see, we are generally the whole human population, we are not prepared for all this. We are still lack of technology to overcome the challenges that I have discussed just now. So we really need the youngsters, okay, the young, okay, to actually start to actually look into all this seriously, and perhaps, okay, to overcome the challenges and come up with the technologies that we need for us to live underwater. Okay, so in terms of food supply, okay, this is actually, I think, Italy. They built a few this so-called sphere, and which is called underwater greenhouse. Okay, they actually have grown some plants inside, including basil, strawberries, and so on. Okay, which is very successful. Of course, this is actually close to the water surface where the plants is still able to get some light, okay, from above water surface, okay, and it's very good because the temperature is actually stable. There's no spike change in the temperature in the water and so on, so it's actually quite successful. I will leave about 10 minutes for the Q&A. I think less than 10 minutes, about 5 minutes. So I'm going to end my talk here. So there are a lot of challenges that we are going to face, apart from technology, in terms of the laws and orders, as well as the willingness, political willingness of the governments and so on. Okay, so an intermediate solution, some intermediate solutions, okay, for the near future will be, we try to actually make our Earth, right, under sustainable development. Okay, we actually develop sustainable and take care of our Earth, okay, carefully. Then consider floating cities. Okay, there are a few models like Oceanics is actually being approved by United Nations, UN, okay, and others. So here I've actually listed 4. I'm going to show you some of the pictures, and the other one will be dual habitable society on land and underwater, or if combined with floating cities, then will be 3. So this is the first floating city. Is actually the company is actually looking for the country to the government to actually test one this. Okay, so this city actually consists of 6 units. Okay, and each unit is actually so-called able to occupy about 250 to 300 occupants. So for this is about 2,000 plus 3,000. So this is a small city. Okay. So the next one is green float, or with so-called forest, plant, factories, seaside cities, beach, and so on. Okay, this is about 5,000. So another lily pads. Okay, these are already designed. Okay, so what is missing is actually the political will of the government, the funding, and so on. And also seastat. Okay, this is actually a project that is so-called probably undergoing. Okay, it's actually started, I think it's by the French government also. Okay, so this is actually floating city. So these are intermediate solutions, as I mentioned. These floating cities actually try to overcome the climate change caused by the global warming, seawater rising, and flood. Okay, so it doesn't actually like try to overcome all. Okay, so as you can see, they will still actually facing this spike in the temperature and so on. Okay, so if the storm hurricane comes, it will still actually affect the structures. So this can only be intermediate, probably for the next 100 or 200 years. Okay, so I stop my presentation here. So I will take some questions.
Yeah, thank you, Mr. Lee. So we will go ahead and take some of the question now from the participants. Okay, I think it's like you have 2 questions posted, Mr. Lee.
Yeah.
Okay, the first one is, what is the outcome if most of the seawater area has been converted to underwater?
I think converted to underwater habitat, which is actually very unlikely because, as I mentioned, the sea covers 75%, 71% of the Earth's surface, and currently our human population is only populating less than 20% of the Earth's surface on Earth. Okay, not including the ocean. So it's very difficult to actually like fully converted the undersea area into underwater habitat. Okay, but bear in mind also the depth of the ocean. Okay, for the deepest, I think it's a few thousand kilometers down. So the possibility is very high. Depends on the technology that we have. Okay, so before that happened, okay, before the human actually migrate all into the underwater habitat, right, probably we have to split the society into 2. Some of them living on land, right, which with lesser population, hopefully the threat and the harm to the environment will be lesser, then the earth will be restored and become more habitable. Okay, so by that you will not actually like overpopulate the seawater also. Okay, the next question. is
Okay.
underwater activity like tsunami will affect the structural integrity. Actually, tsunami happen on the surface and it actually close the coast. Okay, if you actually study tsunami, okay, at deep sea, right, the only effect will be the wave getting slightly higher only. Right, the effect of tsunami only comes when it is close to the shore, where the wave will be very high and so on. So if we have underwater city, which is actually not too close to the shore, or not too close to the coast, then it's actually quite safe for the tsunami. The only few so-called natural disaster that we have to so-called pay attention will be actually the underwater earthquake, and of course the cyclone, underwater cyclone, which is seldom happen. Cyclone happen when there's a change in the temperature. When the temperature at certain point in the water actually gets higher, then there will be actually cyclone, and the cyclone will slowly actually move up to the surface also. So we seldom hear about this underwater cyclone or storm and so on. And tsunami definitely not underwater. So to avoid the earthquake, then we just need to actually build the habitat on safer platform, okay, underwater platform.
Okay. If just a reminder, if you have any other question, you can type your question on the Q&A box.
So I guess no more questions.
I think, yeah. Okay. All right. Thank you, Mr. Lee. Thank you for the sharing. Okay. So for our participant, remember to inform to fill up our feedback form. I request the link into the chat box. Okay, I just posted it. So thank you everyone for joining us for today's webinar. We appreciate for being here. And then we hope that you can fill up our webinar feedback form. So your response is very important for us in helping us to assess the effectiveness of the webinar. And thank you. We appreciate your being here. If you'd like to know more about KLESF virtual events, please like our Facebook page, Kuala Lumpur Engineering Science Fair, KLESF. We will update our virtual event at our page from time to time. Thanks again for joining us today, and we will see you again next time. Thank you, Mr. Lee.
Yeah, thank you,
Okay,
Maria.
thank you, everyone.